Hi, this is Ariella Levine, and this is my problem for week 4. I chose to do problem 11.13 for this week. So the question 11.13 was to run the retirement model from example 11.6 with a damping factor of 1.0 instead of the example of 0.98. It was supposed to use the rest of the same information that was used in 11.6, including the 3 models, which we'll go over in more detail in just a second. And then it asked me to explain what the damping factor, the effect it has on the simulation would be, and then comment on the differences between the simulation results and those in the example. So for 11.6 example, it was all about an investment strategy for an attorney named Sally Evans. So she, at the age of 25, determined she's got 40 years left of saving for retirement, but she wants to start investing now. So she's determined at the beginning of every single year she's going to input $1,000 into her retirement fund. And then she's going to do a variation of strategies for investing, T-bills, T-bonds, and stocks. So she's got all kinds of historical data to help base this upon, but she wants to try 3 different simulations essentially of what percentage of her $1,000 investment goes into all 3 of these options. So we're going to flip over to the historical data. So from the year 1946 to current year, less than current year, the year 2007, more currently, she's got the results of the investments for those years, what went up, what went down, and then of course adjusting for inflation. Now, we've assigned probability weights to that. Showing the 1.0 is not ideal for this, but let's just flip to the 0.98 damping factor. So we've said we want the most recent year to be valued at a value of 1, but each of those previous years we want a damping factor to apply on top of the year prior. So essentially what this damping factor is saying is, we want a higher probability of the more recent years, because honestly, so much has changed across the world. More recent years have a higher likelihood of being actually what occurs in the market. Now, of course, we can take things in historically, but realistically, we want probability-wise the more recent years to come up more frequently. Now, these are probability weights. To get a true probability at 1.0, we took all these weights and divided it by the sum down at the bottom, right? So the more recent year has a 0.28 probability versus historically 0.082. So there's not a significant difference in all the weights, but if you're comparing 0.028 to 0.082, yeah, you see a slight increase in the likelihood of seeing years like 2007 rather than 1946. So with these damping factors, it all weighs into our likelihood of pulling that year as a scenario. So for example, say we're running a simulation and we've used our risk discrete to say I want to pull, based on a probability, I want to pull a year to utilize as my basis. So year 1, we're going to say behave like year 2005. Based on that and using, say, index 1, scenario 1, the results for that year we're going to have multiplied by 0.1 here. And we're going to have this all built in with inflation. We're going to multiply all this together, saying that I want to take these rates from 2005, multiply them by the percentages she wants to put in each of these models, and we're going to have an amount of cash at the end of the year. So after the first year, we had a cash of $1,045. So we're going to combine that plus another $1,000 investment. Remember, this is a yearly investment, and we're going to roll that into the same thing. This time it's going to return a year of 2003, and these are the results of 2003. T-bills returns, T-bonds, and just stocks, and then the inflation for that year. Again, we take all that information, we multiply it all together. Well, every time I hit enter, it's going to refresh, but you get the idea. All this comes together times multiply the weights of what she wants to invest in, and then we roll that all together year after year to come to a total value in this scenario with the risk, $475,570. Now, we've also had a column of deflators coming based on the inflation amount. So the deflators adjust for what it is in the current year, removing the inflation of these dollars to show what the true value would have been in today's dollar value. Right, so I've done this previously just so it moves a little bit faster, and I want to show you the difference in the model in the results between damping of 0.98, where you see we've got just a little bit of different values. Means here 155, 105, and 72, 495 based on the different simulations, right? We also have different values for the 1.0. Excuse me. We've got a mean of 153, 99, and 64. Well, it's hard to say next to each other if the damping of 1.0 has automatically said we're going to have more or less dollars. What I do know is the impact it has on the years being chosen. So I know we flipped to this briefly before with the historical data. 1.0 was a terrible example for what we had done with the dampening factor, because remember what I said earlier, we started with a 1.0, but we wanted to essentially give the current years a higher likelihood of being chosen, because that's probably more akin to what we'd see from results today. When you make it 1.0, there's no divisor. You're dividing the previous time by 1.0, and anything divided by 1.0 is going to be exactly what it was. There is no change, versus with a 0.98, we saw a slightly decreasing likelihood as we went further back in time. So again, that 1.0 makes everything on an equal playing field. There is no difference in the probability between the years, so you have just as high of a likelihood as pulling back 1947 as you do financial results from 2007. So I truly do believe that it does have an impact on the validity of the information we're getting. I do believe the information we should be pulling is hopefully more recent years is a higher likelihood, because that's probably the trend we're going to see. We've got all kinds of different industry, all different types of financial stuff happening in the markets today than from, say, 1942. So we would want the current years to have a little more weight. Now, some of these examples, it depends on risk again and probability, but I'm seeing a lot of 1949s and older years intermixed in there versus, say, let's do this. Let's do a 0.98 damping. We see a lot more of the more recent years and a lot less of the 50s. We see a lot of 2000s, a lot of recent 99s, 98s, kind of thing like that. So that's the impact of the dampening factor. And you see here on the historical data tab, the statistical likelihood of seeing each of these years changes as you, well, not the yearly investment, but as you change the damping factor, each year has an even likelihood of being pulled, the results being pulled, and us seeing that in our simulation model. So I hope this answers the question, and I look forward to working on next week's problem.